Right, here we go. Vectors lesson 2. This time we're going to have some axes and stuff. So we're going to do things with our vectors today. Like add them, subtract them, and do scalar multiplication with them. Okay, here's an origin. Let's have a point, I don't know, let's say here, and call it A. Where is A? Well, it's 2 across and 1, 2, 3, 4 up. So A is the point 2, 4. That is its position vector. How do I get to A if I'm at the origin? Origin meaning starting point, beginning, where things come from. Just look up in the dictionary. So if I'm at origin and I want to get to A, I need to do this. Specifically, I need to travel along the vector 2, 4. That's it there, written in component form, 2, 4. That's the instruction, go right 2 and go up 4, whereas that is the location in space. Okay, quite often we'll just use little letter a to denote the vector of how do you get from the origin to A. So just some notation for you, OA as a vector, with a little arrow above it to show it's a vector, means the vector that goes from the origin to A, and we're just going to write that as A for the vector for a shorthand. Okay. Okay. There could be a vector B. Let's have a vector B. What should we make that? Let's make it 1 across and down 3. Let's do that. Okay. So I could follow that instruction, go right 1 and down 3. From starting at the origin, the original place, right 1, down 3, that's here, okay? So that, let's call it the point B, and that's going to be what happens if I follow the vector B from the origin. So we could write, to get from the origin to B, what you do is follow this vector instruction B. But I could equally go right 1 and down 3 from like literally anywhere in the whole universe. I mean, let's just start at A, shall we, for fun? So starting at A, going right 1 and down 3 gets me to here. And what have I done there? I've followed this vector here. This is very unhelpful. This vector here was called B, and it was the vector going right 1 and down 3. Should we call that C? So the question, I guess, you could ask yourself, how do I get from the origin to point C? Well, there's a few ways of thinking about it. One thing I could do, starting the origin, is I could do the instruction A and then do the instruction B. So I could say to get from O to C, I could do A and then B. What's a clever way of writing that? And. A and B. If I do A and B, or A and then B, I get there. Another way of doing it, I suppose, just for fun, I could start at the origin, OC, and I could do B, and then I could do this. I could go like that. Any guesses? Any guesses what this is? It's right 1, 2, 1, 2, 3, 4. So this is the vector 2, 4. And by some miraculous coincidence, that is what A was in the first place. A was that vector 2, 4. So another way of getting from the origin to C, I could do my B plus A, and happy days, guys, right? It works just like real life with normal numbers. You can add them up in either order and you get the same thing. 2 plus 3 equals 5, 3 plus 2 equals 5. Doesn't matter what way round you do it. That's good. Excellent. So we can now add vectors. Let's suppose I want to go on a bit of an epic journey. And I want to do this, and then I'm going to do that again. Okay, so that's down to here. Doing another B right there. And then we're going to do that again. Doing another B right there, down to here. Okay, how do I get to there? Let's call that point D. So to get from origin to D, what I do is I do B and B and B. Now, because I'm a mathematician, I like being organised and efficient. So what's a clever way of writing that? Let's just do B 3 times. Let's just do 3 B's. I'm going to do B, then B, then B. And what that means is just 3 B's after each other. Okay, same as normal. Oh, I know you can't see it. Oops, my bad. So yeah, here we go. Here's point D, just going B, B, B again. Or 3 B's in a row. 3B being the same as B plus B, B. Good. Okay. Now I've done adding. I promised you addition, subtraction and multiplication. Here's multiplication, scalar multiplication. 3 of them just means literally do 3 of them. So subtraction is left. Well, what do we think we mean by that? So say I'm at D here. Say I want to go back again to there. To go that way is going along B. What do you reckon this instruction here? Undo B, please. Go backwards along B. Negative B is going backwards along B. If I want to go back again, I want to go minus B again. Okay, so I could say, for example, to get from this point to this point, the vector B location to origin, that smells bad, BO, that is minus B, that is going backwards along B. We should probably also do some maths on this side, actually, shouldn't we? I like maths. So here we go. We've got A, we've got B. A plus B, what is going to be A plus B? What does that mean in total? Go right 2 and then go right 1. So in total, go right 3. Go down up 4 and then go down 3. So in total, go up 1. How have I done this vector addition? I've added the instructions to go right, and I've added the instructions to go up / down. So 4 minus 3 equals 1. Okay, same thing we can do here. B is 1 minus 3. A is 2, 4. 1 plus 2 equals 3 on the top. Minus 3 plus 4 equals 1 on the bottom. And I get the same answer. We knew that already, that these two give me the same answer. 3 B's, I've got 3 times 1 minus 3. 3 times 1 at the top is going to be 3. 3 times minus 3 at the bottom is going to be minus 9. So there we go. This is my vector 3b. Okay, is 3 times the top, 3 times the bottom. Just like expanding brackets normally. Do your stuff at the top, do your stuff at the bottom. It's all good. Minus b, I guess we could write that then as minus 1 minus 3. And again, it's like expanding brackets, I guess. At the top, I've got minus a 1, minus 1. At the bottom, I've got minus a minus 3. So that's undoing minus 3. So that's going to be like going plus 3. And this should be my minus b. Let's check. If I start here and I go left 1, up 3. So start here, left 1, up 1, 2, 3. I get back there. Great. Sorry, I drew it wrong. Start here, go left 1, 1, 2, 3 up, I get back there. Start here, go left 1, 1, 2, 3 up, I get back there. So negative, just stick a negative sign in front, expand the brackets kind of thing. Adding and subtracting vectors, that's all there is to it really. Anything else worth mentioning? Okay, one final thing for this week. Let's have A, B, like this. Going from A to B. So let's look at my picture. Okay, so you can see that there. So to get from A to B, I'm starting here and I want to get there. How do I do that? Well, my instructions look like this. I can go along B and then, this was an A here, remember? And then backwards along A. So to get from A to B, I can go forwards along B and then backwards undo A. Forwards along B and backwards along A. Or I can start here, I can go backwards along A and then forwards along B. Doesn't matter which way around you do it, they're the same, they're equal, okay? This is kind of a very useful fact. Now, we can do it, we can just do it by looking at it very easily. So B is the point 1 minus 3. And I can say to get from A to B, I'm going 2, 4, it's a bit of a cliche, and going from A to B, which is like that. How do I get from there to there? Well, what I have to do is go left 1, go down 1 in the x-coordinate, so that's minus 1. How do I get from 4 to minus 3? I'm going down loads, guys. I'm going down minus 7. Okay? What do I get if I do this? Well, minus A is minus 2, 4. plus b is plus 1 minus 3 there. Okay, so minus 2 plus 1, that gives me 1. Minus 4 plus minus 3 gives me minus 7. And there we go. Okay, oops. That is the same as this. Sorry, this was cut off. So basically, to get from 2 to 1, you go down 1. To get from 4 to minus 3, you go down 7. Okay, and you can see that it works out just by doing the normal maths, by going across each, the top and the bottom separately. Okay, same thing if you've got 3 coordinates, top, middle and bottom. Do them all separately, just do what the instructions say. Hope that helps.